Exercise 4J, linear modeling, page 274 of your textbook. Now, do not questions based on content from exercise 4H as I mentioned earlier. We're going to find the length of the segment joining -4 and 3 and 3, -1, correct to 2 decimal places. Again, 2 decimal places, I'm not expecting to be calculable by hand, so just do it in the calculator. I'm assuming that you guys are okay with me using the Pythagoras approach, sorry. If you use the formula and you get the same answer, that's completely fine. You'll never be asked to do one way or the other as long as you get the correct answer. So -4, 3, I like to approximate what it might look like. So -4, 3 would be up here. -4, 3. Just make sure not to switch around your x's and y's. 3, -1, I'm going to say is down here. So connecting those dots and forming a right angled triangle, there we go, gives me, well, the distance from -4, I'm focusing on my x values, from -4 to 3, that's 7. And then vertically, from -1 to 3, that's a difference of 4. So using Pythag, C, let's use C squared. C squared equals to A squared, let's call that 4, so 4 squared, plus B squared, which I've accidentally written B, which I mean 7, so 7 squared. This gives us C equals the square root of 4 squared is 16 plus 49, which equals, and I'm going to put that straight into my calculator. So I go 16, not 16, sorry. I'm going to find the square root button, 16 plus 49, which is 65, and we square root that to give us 8.06. Any questions? Great, I feel like you guys are already experts at this one. But I'll scroll back up to that one in a moment, but let's move down to this section here. What I'm going to ask you guys to do is to very briefly, in your own words, I want you to cut this down. I want you to write this into your notebooks. So linear modeling, again in your own words, just write down the steps 1, 2, 3, 4 in your own words. In your own words. So instead of writing, for example, find the rate of change gradient, you can just write find gradient. Can you hear me up the back? All good? Lovely. That most definitely should say find the rule. My apologies. Right. Okay. So linear modeling, the concept of modeling is very weird, but the idea is that we can use math to try and replicate real life. Just like if we're trying to send, for example, a rocket into space, a lot of people think it's really easy, and it's just shoot the rocket up, but there's a lot of different forces, different things at play. So what we like to do is perhaps run a path of a simulation of what that rocket might do, or what in terms of its path, and we can use math to replicate that. When you're, for example, we're looking at real-world situations in linear modeling, if we're talking about the cost to hire something or the cost to use something, that could be linear. If we're talking about the path that a ball takes when you throw it, that could be also modeled using mathematics. Not linear, but in other mathematics as well. So modeling just means to replicate real-life scenarios using mathematics. And oftentimes, the reason we replicate it is so that we can make estimations or predictions. So if my data points, for example, between 5 and 6 minutes, I can use my linear modeling to predict what 5.5 minutes would look like. If it's only 5 to 6 as my data points, I can use my linear modeling to predict what 8 minutes would look like. So that's what linear modeling is. There are 4 main steps we're going to be focusing on. The first one is find your gradient, which I do want to reinforce the idea that the gradient is the rate of change. Anytime you see a rate, 50 kilometers an hour, $60 per liter, whatever it is, any rate, that's your gradient. Second is to find the rule. It means to just find the equation. Third one is to sketch it. And the fourth one is to use your graphical rule to estimate a value. At the end of the day, they are estimates because we don't have those exact data points. I'm going to go through an example. I'm going to say you don't need to copy this example down because you'll be doing a lot of these in your notebook through the exercise questions as well. But I would like us to follow along. A salesperson earns $500 per week plus $10 for each item sold. Now, is there a rate? Immediately, is there a rate in this question? Is it the $500 per week, or is it $10 per item? It could be $500 per week. Thing is, right? Technically speaking, they're both rates. But the equation, and we didn't read further enough, my apologies, but it says write a rule for the total weekly wage if a person makes X sales. Yes?
W equals to 500 plus like 10x.
That's perfect. So the $10 per item, we're assuming a 1 week salary, by the way, or wage, sorry, 1 week wage. It's $10 per item. Per item, that's a rate. So the gradient would be 10. So if I was to write a rule, it would be W dollars, because that's what the question's given me, by the way. Their wage is W, equals 10x, because that's $10 per item, plus 500. Because no matter how much he works in that week, he or she works in that week, they get that $500. Draw a graph of W versus X for 0 to X to 100. Now, what does this thing mean? You will see this a lot in this exercise. What does that mean? What does that mean in words? So we know that X is the number of items. Yes, Abby?
0 is smaller than or equal to X, which is smaller than or equal to 100.
Exactly. Now, can anyone off the top of their head, and Abby, you're welcome to answer this if you'd like, what does that mean which is different to that?
The one that you just drew is just larger than or smaller
Correct.
than, but with the extra line it's
Absolutely. So something that we'll really try to drag out of you is explaining what something means in context. So in context meaning in relevance to this question. If I said, what does that mean? And you answer 0 is less than or equal to X, which is less than or equal to 100, technically you're right. But what I'm asking for is you to say the number of items sold per week must be equal to or greater than 0, but less than or equal to 100. So the least items this person can sell is 0, and the most they can sell is 100. That's it. So if we're trying to draw a graph of W versus X, would X, so the number of items sold, would that be on the horizontal or on the vertical? And how do we know? Have you guys done independent dependent variables in science before? Not if you remember, I'm assuming no, but have you guys done them before? Yeah? So your independent variable, IV, let's call it, always goes on the bottom. So independent is the one that doesn't care about other things. It's a good idea to write this one down. And your dependent variable goes on the vertical. So for example, if we're saying that time versus temperature, let's talk about temperature throughout a day. Does the temperature depend on the time of the day? It does. So that would be the dependent variable. Does the time care about what temperature it is? No. So that would be the independent variable. In this case, we've got wage, so the amount of money that person gets, and how many items they sold. Does the number of items they sell change what the wage is?
Yeah.
It does. So the wage would be the dependent variable and therefore the vertical one. Does the wage change the number of items they sell? No. So that would be the independent variable, the number of items sold. Great. So if we're drawing a graph, this one, let's call that X and this one W. Right? 10x plus 500. Immediately, I know that the starting value is going to be 500. So that's my y-intercept. So that's going to be 500. And it's going to go up like this. How do I know it's going up? It's going up because it is positive. Perfect. And yes, you're right, 10. So the gradient is positive, which is positive 10. Now it says from 0 to 100. I know what X is, so I know what W is, my apologies, when X is 0. When this person sells nothing, they get a wage of 500. At 100, and this is important that we include what we call an end point, by the way, which is just the point at the end. I know, crazy. I need to substitute 100 into my equation in order to find what their wage is after selling 100 items. So I'm going to go to W equals 10 times 100 plus 500, which gives us an answer of 1,500. So that one I would just label. It's okay for you to write this as well. Oops. But I would also just label the point 100, 1,500. So now our graph actually shows going from 0 to 100. How much does a particular salesperson earn in a week if they make 25 sales? We do the same thing we just did. So for C, we would say W equals 10 times 25 plus 500, which is 750. Thank you. $750. Now, the last one here is a little bit trickier. It says, in a particular week, the salesperson earns $850. It's important for us to understand or identify which variable that is. So if they earn $850, which variable is that we're replacing? Thank you. The W, the wage, not the number of items sold. So in this case, apologies for the mess of where things are. In a particular week, they earn 800. So W equals 850. So 850 equals, and I'm going to replace W with 850 and rewrite my original equation, which is 10x plus 500. And then we just solve as per usual. So minus 500 on both sides, we get 350 equals to 10x, and therefore x, I'm going to move down a little bit, therefore x equals to 35. I'm going to write 35 sales, just so we're clear. Any questions? Great, thank you very much.